Welcome to the next episode of the multiplayer inventory system. Today we'll create the widget for the storage box and adjust the controller. Go to the folder Inventory System, UI, Widgets, Inventory. Duplicate the WB Inventory widget and rename it to WB Storage. Open it and start in the designer. Right-click on the overlay and duplicate it. Select the duplicated overlay and change the anchors. Hold down the Shift plus Control keys and click on the center top anchor symbol. This places it at the top center. Now change position X to 300 and position Y to 150. Select the upper overlay and repeat the step of setting the anchors. Change position Y to 150 and position X to -300. Select the text of our overlay and change it to storage. This will represent the storage inventory. Select the container of the lower overlay and rename it to WB Storage Container. Select the container of the upper overlay and rename it to WB Inventory Container. Now switch over to the graph and select the node with Set Inventory Ref to duplicate it. Connect the execution pins as a continuation to this node. Now take the variable WB Storage Container and drag it slightly over the name of the variable in the graph until the hint appears that you want to replace it. Create a new variable named Storage Inventory Ref. For the type, choose BPC Inventory. Mark this variable as instance editable and expose on spawn. Take this variable and drag it onto the inventory ref pin of our storage container. Compile and save everything. We'll now close some unnecessary files and focus on the storage box. Here, we need to ensure the widget is created through the GetWidget interface. Expand the section for implemented interfaces and double-click on the GetWidget function. We see that during its initial creation, we mistakenly placed the output parameter in the input section. To correct this, open the BPI Interact interface and select the GetWidget function. Before adding the output parameter, delete the existing input parameter. Then, create an output parameter named Widget and set its data type to userWidget object reference. Save these changes and return to the storage blueprint to continue. Now we can proceed to create the widget. Connect the execution pin and search for the Create Widget node. Link the return value of this node to the widget pin of the return node. For the widget selection, choose WB_storage. Expand the variables category, navigate to Components, and drag the storage inventory variable onto the storage inventory ref input pin of the created widget. Make sure to select the storage inventory component and, in the Details panel on the right, enable the checkbox for component replicates. Save everything. With this step, our storage box functionality is complete. Currently, saving the accessing characters variable in the storage blueprint may not have much practical use. However, it can be utilized for additional features like playing a sound effect or triggering an animation to open or close the box when someone accesses the storage. If you'd like to see a demonstration of how to implement this or have ideas for other features, feel free to mention it in the comments. Next, return to the player controller. Clear some space at the bottom as we will be adding several new functionalities here. Create a new custom event named ShowWidget. Add an input parameter named Widget and set its data type to userWidget object reference. From the IA inventory nodes, select all related nodes and move them to the level of the ShowWidget event. Disconnect the link to the IA inventory node and reconnect it to the ShowWidget event. Drag the Create Widget node down to the IA inventory logic and rearrange the connections. Remove the unnecessary links between nodes. Connect the widget pin of the showWidget event to the set node of the openWidget variable. Organize everything neatly. Expand the IA inventory node and connect its started execution pin to the create widget node. For the owning player pin, set a self-reference. After the widget is created, call the showWidget event and connect the return value of the widget to the widget pin of the event. This setup centralizes the logic for displaying widgets, making it reusable for multiple instances. After writing the widget into the openWidget variable, call the setOwningPlayer node. For the local player controller input, set another self-reference. Select the entire showWidget event and add a comment labeled showWidget to enhance the organization and readability of the blueprint. Next, we'll set up the interface event access actor. Add the event to the graph. Take the actor pin of the event and promote it to a variable named accessing actor. Create a new custom event, as this will execute on the client. Name the event accessing actor client. Set its replicate property to run owning client and mark the event as private. Add an input parameter named actor with the data type actor object reference. From the actor pin, call the interface function getWidget. Chain this to the showWidget event, connecting the widget pins from both nodes to ensure the widget is displayed correctly for the interacting actor. After the actor is written into the accessing actor variable via the interface, call the accessing actor client event. Pass the accessing actor variable to the actor pin of the accessing actor client event. Select both events, access actor and accessing actor client, and add a comment labeled access to any actors and display widget for better structure and understanding of this functionality. This setup ensures that any actor interaction will trigger the associated widget display for the client. Now we need another custom event named stopAccessingActorServer. Drag the accessing actor variable into the graph as a getNode. Right-click on this node and convert it to a validated getNode. Connect the execution pins to ensure it only proceeds if the variable is valid. Next, search for the getControlledPawn node. From its return value pin, call the getCharacterRef interface function to retrieve the character reference. Connect the isValidExecution pin from the validated getNode to this function. Drag the accessing actor variable into the graph once more as a getNode. Use this to call the stopInteract function from the interface, passing in the character ref obtained earlier. Finally, reset the accessing actor variable by connecting it to a setNode with no value. Mark all these nodes, group them neatly, and add a comment labeled Stop Accessing Actor and Cleanup. This ensures a clear workflow for stopping interaction with an actor and resetting associated variables. Now let's move higher up to the interface event closeOpenWidget. Double-click on it to edit. Clicking will take us directly into the interface blueprint. In the interface, select the closeOpenWidget function and add a new input. Name this input IA action key and set its data type to object as an object reference. This will represent our enhanced input action. Save the changes and return to the MyPlayerController blueprint. Here, take the IA action key pin and connect it to the equal node, where IA inventory is checked. This makes the key dynamic. The logic ensures that if a widget is opened using a specific enhanced action key, that same key can close it. However, for other widgets without a dedicated key, such as the pause menu, the escape key can still be used to close them. Now create some space between the branch node and the remove from parent node. From the true execution pin of the branch, call the stop accessing actor server event. This ensures that when a widget like the storage widget is closed, access to its associated actor is also stopped. After the remove from parent node, reset the open widget variable by connecting it to a set node with no value. Now navigate to the Inventory System, UI, Widgets, Inventory folder and open the WB Inventory widget. In the event graph, access the onKeyDown function. Set the input action to IA UI Inventory. This ensures that the inventory can still be closed using the tab key, maintaining expected behavior for user interaction. Next, open the WB_storage widget. Go to its graph and locate the onKeyDown function. Similarly, set the input action to IA UI Inventory. Compile and save your changes. After this, open the main HUD widget and also navigate to its onKeyDown function. Here, leave the IA key empty. However, note a potential issue. If the widget focus is lost from either the inventory or the storage, users will no longer be able to close them using the tab key. This bug is intentionally left unresolved to highlight its implications. A partial solution to this issue would involve setting both the I and tab keys for inventory control, then creating an additional input action called something like IA UI close widgets. Assign tab and escape to this new action. While this approach would work partially, it might conflict with other shortcuts. If you'd like a detailed and well-structured tutorial addressing this problem thoroughly, let me know, and I'll develop a robust solution for you. Finally, be aware that the editor may sometimes display an error when closing the inventory using the escape key. This occurs because a for-each loop continues running after the widget is closed. The loop doesn't break and repeatedly attempts to remove the widget from the parent, even after the widget variable has been reset. This issue will be addressed in upcoming episodes as we further develop the storage interaction system and add full functionality to the storage box. If you found this tutorial helpful, leave a like or subscribe to ensure you don't miss future episodes. Thank you for watching, and I wish you a productive and creative time building your game.